Okay, so this is a problem that is very important to comprehending what we're doing with the p-series. So the fact is that we know that this guy goes to infinity, but something like this actually does not go to infinity. It goes to a constant, okay? And this is to try to build some intuition as to why this is happening. Right, so we're going to just rewrite 17 trillion as 17t for now, and x to the minus 1.1. So then think about it. If you owe $1, 10 cents, and somebody gives you $1, then you owe 10 cents, right? So if I add 1 to minus 1.1, I still get minus 0.1, and I divide by the new exponent, okay? Okay, what does that mean? Well, let's figure that out. This denominator here is minus 1/10, but it's in the denominator, so it's really minus 10. And that x is also in the denominator, so it's kind of like the 10th root of x. And you've got something big like 17 trillion, and you've got a 1 here, okay? So you can flip the direction of the integral if it helps you visualize this, okay? Because if I have a minus sign, and I can flip these guys, get rid of the minus sign and flip the limits of integration. That's legal, as long as you do them together. Okay, so then what you get is 10 over the 10th root of 1 is 1 minus 10th root of 17 trillion. Now, you can think as 17 trillion gets higher and higher and higher, this whole term is going to wipe out. So the limit of this thing is actually going to be 10. But is this 17 trillion far enough out? Are we capturing most of that area? Well, if you have a calculator, you can just figure that out. But let's pretend we don't have a calculator and figure out, instead of using the 10th root, I'm going to use the 8th root. Instead of 17 trillion, I think I'm going to use like 16 because it's easier to figure out. And just make approximations when necessary. I mean, this is really, really close, right? Okay, so if I want to take the square root of this guy, I get rid of half of those zeros, and the 16 turns into a 4, and then the 8 is going to turn into a 4. Okay? Now I want to take the square root of this again. So the 4 is going to turn into a 2, and I'm going to get rid of half the zeros. And so now I just have a square root. So it's the square root of 2,000. I don't know. But I know that 10 squared is 100, and 100 squared is 10,000. So it's somewhere between 10 and 100. What about 20? 20 squared is 400. 25 squared, I would like to know. Yeah, I'm pretending I don't have a calculator. 625, but you know what? 30 times 30 is 900. So that's definitely getting closer. What about 35 times 35? I mean, it's somewhere between 30 and 35. So we could just make it 30. It's close enough. And we're just doing eyeball. Okay, so we're going to be doing 10 minus 10 over something in the vicinity of 30. It's like 10 minus a third. So it's approximately 9.7 or something like that. Okay, so do try to figure out if it's a large or a small answer. Well, it's not a large answer. It's not like going to a million or a billion or a quadrillion. It's not a particularly small answer. It's not 0. It's not a tenth or a millionth. It's just kind of an ordinary number. It's about as ordinary as you get for sizes of numbers. Sizes of numbers are all relative. But relative to this being 17 trillion, you know, this is just kind of, it's not huge, and it's not teensy, teensy, tiny either. So it's just blah. Okay.